Hi, Assalamualaikum. In this video, I will explain about how to choose the subinterval that the root lies in bisection method and also false position method. These two methods are categorized under bracketing method. As we all know, these two methods are used to solve for the root of an equation. As you can see here, the algorithm for both methods are likely the same except for the formula in computing the approximation root XR. False position method is the improvement of bisection method. If you use false position method, your approximation root will converge faster to the actual root of solution. The algorithm or the steps involved in finding root using bisection and false position method are very simple as compared to open method. The difficult one is only in step number 3. But before that, for the first step, you must choose the lower guess XL and the upper guess XU. And the next step, you must compute the approximation root. For the false position method, you must use this formula. But for the bisection method, you must use this formula. For step number 3, you must use these evaluations to identify the subinterval that the root lies. As I explained in class, I didn't use this evaluation. I used another evaluation and it is a bit different, but the meaning are the same. So no worries if you still use this evaluation here. Make sure your table should look like this. But if you follow what I have explained in class, your table should look like this. Let us look at one example here. Given function fx and also given the initial condition 1, 5. So this one here is your lower bound xl and 5 is your upper bound xu. And the stopping criteria is 8%. So you must stop your computation until your epsilon A less than this 8%. So in this example, you must use bisection method to find the approximation root XR. So in your table, for the first iteration, and this is your XL, XU, and then you must find your F of XL and F of XU. Just substitute these two values into your function fx. And after that, you can find your approximation root XR by using bisection method formula, which is XL plus with XU divided by 2. And after that, you must find the F of XR. You just substitute this XR value into the function fx. Okay, for the second iteration, how to choose your subinterval. This is your subinterval XL and XU. So based on the previous iteration, as you can see here, your f of XR, the value is positive. So this value here, the sign of it is the same as the sign of f of XL, which is positive sign. So you must replace your XL with XR. That's why I put the value of XR 3 to this XL. And the value of your XU still the same as previous one, which is 5. Okay, next, just find your f of XL and f of XU. And also you can find your new XR. And then find the f of XR. After that, compute your epsilon A. And since this epsilon A does not satisfy the stopping criteria yet, so you must continue your computation. So for the third iteration, your f of XR here, the sign is negative. So this sign is the same as the sign of f of XU. So for the next iteration, you must replace your XU with the new value of XR, which is 4. Okay. So your XL is the same as the previous value of XL, which is 3. And then you continue the process and you get the new XR, 3.5. Okay. Next, for the fourth iteration, this is your f of XR. The sign is positive. The positive sign is the same as the sign of f of XL. So, you must replace your XL with the new XR, which is 3.5. So, what happened to your XU? So, your XU is the same as the previous XU, which is 4. And then you calculate your f of XL and f of XU, and you can find your the new XR. And after that, you find your epsilon A. And since your epsilon A is 6.67, which is less than the stopping criteria, so you stop the process. Therefore, your estimation root is 3.75 with epsilon A 6.67%. If this example, you must use first position method, the steps are the same as this one, except for the computation to find the XR, the formula to find the XR. You must use the formula of first position method. The rest are the same as this one. This is what I taught in class last time. If you use my method, make sure your table should look like this. But if you use evaluation in lecture notes, your table must look like this. Okay, make sure you have this the addition column here if you use the explanation in lecture notes. That's all for today's video. Thank you and all the best for your test.